All right, good morning, everyone.
Good morning, Mr. Getz.
Okay, today we're going to be taking notes tomorrow, probably through Thursday, maybe even getting into Friday a little bit. So go ahead and get out a notebook, put your phones away, put the earbuds out. Okay?
Phone away now.
We're gonna be rocking and rolling with this today, seeing as far as we can get. As you are doing that, just a quick little reminder. This Friday at 11:59 p.m. is the deadline to turn in your coolant reassessment from the test we took last Friday. If you're one of the students that followed along and paid attention and completed our activity from yesterday, you should maybe already have a point ready to go, which is probably going to be not enough if you were one of the 8 students from first, third, or fifth hour. They got a 57% to be able to get into the passing category. Okay. So I encourage you to go through that reassessment, complete it thoroughly, so then that way you can earn some points back for that. That is going to be by far the fastest, best, and easiest way to increase your grade for second quarter. Okay? You go ahead. Trying to think what else is kind of going on here. I think that's all the announcements I needed to make for right now. So, today we're going to be talking ignition systems. That's our new unit. So what I'm going to do is I'm going to get out my marker here for a second, and remember with your notes in the upper right hand corner, we're going to talk about the topic that we're discussing. So in this case I'm going to write out ignition systems.
What's the date today?
You're going to write your name. I'm going to write my name. And then it is the 19th today.
Are you writing the hour or no?
You can if you want, but you don't need to.
Alright.
Remember, what my goal in showing you guys how to do this is just to be consistent. So that way we're kind of getting the habit and the routine of taking notes in a very systematic way. So then that way it's organized in a similar fashion throughout all the notes you take. So it's easier maybe to find something or even to write down. That's the idea. Okay, when it comes to our standards from ASC for this particular unit, we've only got 2 of them, okay, which is a little lighter than some of the other ones, but it doesn't mean less content. There's still a strong amount of, large amount of content in this. So, standard A8C1 from ASC states that a student, by the end of this unit, you will be able to identify ignition system components and configurations. So, before we move on to the next one, I just want to encourage you, anytime that you see a vocabulary word on the screen, or we're talking about a component, you're going to want to write that down in your notes, because I'll guarantee you that's probably going to show up later on in the study guide, and you're going to need to know not only the name of the component, but what it does, its function, and its purpose. That information will be very valuable for the upcoming test, which, as of right now, this test for ignition systems, I have scheduled for the week before winter break. Okay, so this is going to take us up till winter break. All right, the second standard from ASC, A8C2. Remove and replace spark plugs. That's going to be the lab. You're going to be able to inspect the secondary ignition components for wear and damage. We'll get into what that is here through this presentation. But that's what you're going to be doing out there, okay? So, what we want you to do now is spend a minute here contemplating a question, an essential question, that you're going to write down in your notes that eventually you'll answer later in your summary once we get through all this stuff. Something maybe you're curious about, something you don't know that you want to know. Remember to always use what, where, why, when, how, who to start your question. And you really can't go wrong with this. I want to emphasize, I know I do this a lot, but I want to emphasize the fact that your question is going to be different from everyone else's question. And that's okay. Okay, this is for you, it's not for me, it's not for the person next to you, it's not for the buddies in the class. Okay? What do you want to know? What do you have questions about? Okay, who, what, when, where, why, how. Okay? I'm not even gonna write a question on my whiteboard because again, my question is not better than yours. Yours is just as valid. Okay? Now, key thing here, keep in mind these standards that are up on the screen right now. Base your questions off of this information because this information here is literally what we're going to be talking about for the next 2, 3, 4 days. Okay? By the way, I forgot to ask, does anyone need paper?
I can hand out some papers.
Not gonna pass.
Sounds good, there you go.
Today.
Anybody else? No? Does anyone need a pencil? Need a pencil?
Yes, I got 2 questions, so I get 2 points.
You get double points. By the way, you can ask more than one question. I'm totally cool with that. Not
Double points.
not necessarily just to do one question. Yeah, it's a little loose. Sorry. It doesn't matter what table goes here. It's because it's forced.
Oh, man, who are real busy boys?
I mean, I thought it was.
Yeah, they gotta level it out.
See, I'm not retarded. Oh, he didn't say he couldn't know the answer. He just said ask the
You
question.
got it, Charlie. You got it.
All right, I'm assuming we're good. That's enough time?
Yes, you're good. I wrote my question.
Okay. Again, want to let you know this particular image is going to be many different components in our ignition system, but you must understand the ignition system does not work in isolation. Right? I can't just put a bubble around the ignition system and say, oh, that's everything we need, and it's not going to do anything else beyond that, and it's not going to take any inputs outside of that. Okay? Lots of things, lots of different parts and components are going to influence how the ignition system runs. I'm trying to focus in on the most common components that you're going to see, and we're going to discuss how these components function in order to get the ignition system work. Tim?
This may sound dumb, but like, are the headlights connected to that?
The headlights are not connected to that. No, it's not a dumb question.
Oh, okay.
Yeah. So, let me show you guys again. You don't have to draw details of everything. Okay? This is how I would do it if I was a student. First, I would just, nice big box right there. And then I would come in here and I'd literally probably just drawing like these lollipop type things. When taking notes, it's important that you understand it is going to be messy, it's going to be dirty, it's not going to be pretty, it's not going to be organized, it's going to be sloppy. If your notes are super neat and clean, you're doing notes wrong. Straight up. Okay? Your notes are going to be messy. That's okay. I want you to have fun making messy notes.
Messy.
What was that? Okay, that's how my notes would look. I'm ignoring the gray stuff. Any of the gray stuff we're not going to talk about.
Oh, wait.
Eventually we will talk about it when we get into different units, but right now, again, I'm trying to not overload you with all these things. We're just talking standard fundamental stuff. But then I want to come in and identify this, okay? So like this big square box, that's our ECU, also known as the engine control module
Yeah, shit's sweet tied up.
or unit. Okay, here's my ignition coil. I'm literally just abbreviating. Here's my knock sensor, like knock knock, who's there? Hopefully not a piston. This is my camshaft sensor. This is my crank sensor. Stop. And this is my trigger wheel. Y'all Winnie the Pooh fans? It's like Tigger, but trigger.
Whoa.
You guys don't know Winnie the Pooh then?
I do.
My
Trigger.
grandparents watch that shit.
Trigger, yeah.
OP.
Or like Tigger.
Like,
You guys, listen. Tigger was my favorite. The bouncy tiger.
Yeah, I know that.
yeah,
Like
well,
literally, no.
he's
Like,
just trying to
that's the
get-
reason why I watched Winnie the Pooh back in
He's
the day.
just trying to get
Yeah.
I'm trying to say anything.
So there you go.
Tigger looked at me.
Notice how quick I was able to draw that and label it. Right? We can't be slow. We can't be
slow, bro.
organized. It's not gonna look exactly like it is.
No
Okay?
one gives a fuck about detail.
Hey.
I'm not giving detail, bro. No one gives a freak about your detail.
Look at my drawing, dude.
Yeah.
Oh shit.
Stop. Don't need to use that language.
Rudy, not S-H-I.
Right.
Rudy.
Ignition system's gonna have a lot of abbreviations. Now, some of the stuff we've already talked about previously, right? You've used the digital multimeter in the coolant system. We use that in order to put the red lead into the coolant and the black lead on the negative cable, the ground, and we were testing the voltage difference between those 2 points. Obviously, the higher the voltage difference, the more acidic the coolant was, right? We could infer that information. Now, we're going to be using digital multimeter in a little bit of a different setup for this system, but I do want to emphasize this, that at any point in time, one of the things you should probably have in your toolbox for anything is a digital multimeter. Legitimately. It's used constantly in automotive. It's used all the time just in general electrical work. You can use that all over the place for any job. Now, the multimeters that I have out in the shop that you guys have been using are like $25 off of Amazon. They're relatively inexpensive, but they get the job done. If you're going to go in as a professional auto technician or an electrician, you're probably going to spend $300-400 on a digital multimeter, like no doubt. Yay! Some people ask me what's the best brand for digital multimeter. Fluke. F-L-U-K-E. Okay.
So big.
Fluke is top brand. You're spending $300-400 on this.
What makes them better?
What if I just steal that one?
What makes them best? Their accuracy.
What about the other
I'm not too sure how much that one probably was over $100. They come in a variety of different things, but different price points. I'm not going to get into digital multimeters with you guys right now, but just note that you can probably get away with spending $25 for just learning the tool, and for pretty much 90% of what you probably need to do either on automotive and or around the house. RFI, radio frequency interference. That'll come up later on in the presentation, so I'm not going to spend a ton of time on that now. You've got coil on plug and coil near plug. These are essentially the two of the same things. It's just where they're located. One coil is on top of the spark plug, the other coil is near the spark plug. Same concept though. So COP or CNP. Coil on plug is more popular in 2024, so I'll just point that out. CNP really not too often do we see that. NOx sensors.
KSI?
Okay, knock sensor again. Knock sensor. Knock knock, who's there?
Not your engine.
Well, hopefully your engine, just not your piston. All right, CKP. CKP is your crankshaft position sensor. Crankshaft position sensor, CKP. CMP is your camshaft position sensor. There is a huge difference between the two, obviously, because you know there's a difference between the crankshaft and the camshaft. Okay? So we have two different sensors. They literally do the same thing. Their functionality is the same. They're just, one's monitoring the crankshaft, the other one's monitoring the camshaft. Okay? Now, the reason why we've waited up until this point to do ignition systems is pretty easy, right? You needed to learn how the fundamentals of how an engine works. 4 strokes, piston, components, right? And all that sort of stuff. We're going to be revisiting a lot of information from that. Lubrication system and coolant systems were pretty close together. This one's a little bit more forward in regards to its operation.
When we were doing oil systems, you said that there was something like on the camshaft that the trigger wheel or maybe the crankshaft lines up to.
Yes.
Wow. Is that what you meant?
No. It has a similar effect though.
What is it?
Okay. So the oil pump is hooked up to the crankshaft. So as the crankshaft spun, it spins the oil pump. That's kind of how that works. This one here, it's a wheel that basically it's counting the rotations of the crankshaft. So then that way it knows which cylinder or which piston is on which stroke in which cylinder.
So it just like keeps track of what piston is supposed to be doing what.
Yes. That's a huge thing. Okay, getting into the why. What is the purpose of the ignition system? Why does it exist? Why do we need it?
Boom.
Yes. Okay. Now, I'm gonna stand up here real quick, just fast. If you're writing this entire thing down verbatim, word for word, you're doing it wrong.
Why?
Okay? That's not what note taking is. You're literally not writing down verbatim. You're reading it, you're processing your brain, and then you're basically writing down a highlight of what's talking about, okay? Okay, if you're just writing down verbatim, it's literally passing through your head, and you're not remembering or retaining that information. Does that make sense? Okay? So, ignition system, it produces high voltage. We're going to ignite the air-fuel mixture. And how we do that is creating an electric arc at the spark plugs. See how I can just hit up a couple things there and get the general idea? I don't need everything else in here.
So why even put that there?
Okay, because it's proper English. Keep in mind too, I don't have to write out the word high. I could just literally draw an arrow going pointing up. That's high. So literally, higher voltage needed to ignite the air-fuel mixture to burn it. And we do that by creating a lightning bolt at the spark plug.
Lightning.
Really, really small lightning bolt.
Oh,
So why
is that
should
what
I-
an electric arc is? A lightning bolt?
Yeah.
Oh.
Also, on a side note, in addition to how we ignite the air-fuel mixture, that's the first sentence, it's also equally important that you understand there is a very specific when we need to do this. Timing is critical. If we do not send this little lightning bolt at the exact time that we need to, the engine will not run.
So
Okay.
why should I not eat these?
Because they probably don't taste very well. Okay, now, the question is, when do we spark the spark plug? When the piston is reaching top dead center in the compression stroke. That's when we ignite our spark plug with the air-fuel mixture. Okay, so not only are we talking about what's happening, we're talking about when it's happening. It's equally valid. The what's being called?
Air.
Oh yeah. That's a great question. I got that question first though too. It depends. Depends on the type of spark plug, because different spark plugs can last longer than others. Depends on the type of engine, the type of fuel you're using, the compressor ratio. I mean, there's a lot that goes in. So for instance, if I'm in a top fuel dragster, hey folks, listen to this real quick. You guys know what a top fuel dragster is?
Yeah.
It's the car that's like super long. It's got these huge obnoxious tires.
Yeah.
Right, and they go on at like quarter mile, and they hit green, and they just go shoot flames out, and it goes from like 0 to 60 in like 1.5 seconds. Yeah.
I might know
Okay.
That's my car, but yeah.
Fun little fact about top fuel dragsters. About halfway down the track as they're going quarter mile, right? The spark plugs get so hot they melt to the point where they no longer can ignite the air fuel mixture. So every time they run a race, they have to replace the spark plugs because they're busted.
And like every other component.
Yeah, like basically, you have to rebuild engines between every race.
So like,
So it's crazy.
When I be going that fast,
Yeah.
it's gotta be real.
So in that case, every time you replace, every time you run that car, you're replacing it. If I'm running a hybrid or something, I could probably get them to last quite a long time.
Well, like something like an F-150.
Some F-150s are able to, the spark plugs last about 100,000 miles. So they're meant to last a while. It's not something that you would changing every 3,000 to 5,000 miles like the oil. All right, one thing here, let me go back quick. Can I go back? No, go back. Go back. Okay. Think of the timing as something that you're probably a little bit more related to. If I take a jump rope, has everyone used a jump rope before?
No,
Okay.
never.
If I've used a jump rope, as I'm swinging over my head, as that jump rope makes contact with the ground, it kind of makes a slapping noise, right?
Yeah.
As soon as I hear that, I know I need to jump. So then I jump, the jump rope goes underneath my feet, and then I take it around again, right? Slap, jump. Okay, I've been trained. So I know exact time when I need to jump off the ground in order for the jump rope to make it past my legs, right? However, if I were to wear earplugs and I were to take a blindfold and put it on and I were to start jump roping, I can't hear that, and all of a sudden my timing is off, right? As soon as I do that, that jump rope, I don't jump at the right time, jump rope hits my legs, and all of a sudden, I stop. Okay? That illustration is a perfect example of your engine with the spark plug timing and sparking. Okay? As soon as that piston is traveling up in the compression stroke, compressing that air-fuel mixture, there's this point in time where we need to ignite that air-fuel mixture with the spark plug, so that way that fuel-air mixture is burning and powering the engine. Okay? It's a mechanical wonder that we can get this thing to actually run and operate at the rate at which we do, speed-wise. Now, traditionally speaking, in order to spark a spark plug at the correct time, there's been 3 ways that we've been able to do that. Okay? The first way is this right here. It's called a distributor. Okay? This is a distributor. It's called a distributor because quite literally it distributes, or it points to the cylinder that needs the electrical current to make the spark on the spark plug as it's going around. So this is actually hooked up to probably the camshaft. As the camshaft operates, this turns, and if you look on the inside of this, you can see that I got this little piece that's literally turning with the speed of the engine, and the electrical current's coming out and touching basically these little points, and that has a spark plug wire that leads to the spark plug. So then it says, okay, I need to spark it at cylinder 1, cylinder 3, cylinder 4, cylinder 2, cylinder 1. And it just keeps turning and allows that current to flow. Okay, this is a much older technology. You're not going to see this on any modern day vehicle. Okay. Now, when we go out to the shop, one of the vehicles I know for a fact has an electronic distributor still. You need to know what this looks like because you need to be able to identify it. This is a distributor. Okay? The second type of ignition system is called a distributorless ignition system. That's what this is. There's no moving parts on this ignition system. Okay? So you can see here that I've got 1, 4, 6, 3, 2, and 5. So what happens is the computer says, hey, fire the spark plug. This sends out an electrical current through spark plug wires, to the spark plugs to ignite it. No moving parts. Okay? So this is an evolution of the distributor, but it doesn't distribute it because there's no moving parts. So that's why it's a distributor-less system. Okay? This is oftentimes sometimes called a coil pack, or it's sometimes also called a wasted spark ignition system. You might want to write that down. I know it's not on here. A coil pack or a wasted spark ignition system. Okay, we refer to it as a distributorless. So 3 names, same thing. Just in case someone comes up to you and says, oh yeah, I just bought a car, it's got a wasted spark system. This is the type of ignition system it's got.
only heard coil pack.
Okay, or a coil pack. And finally, the more modern day technological leap is called a direct ignition system. Right here, this is what it looks like. Okay, so literally what we've done is we've gone from the 60s and 70s and 80s, from this, right, to 2024 to this. Okay, this is extremely more efficient than this is. Okay, now keep in mind this worked and it was reliable until it wasn't. This is now computer controlled, and we can actually fire the spark plug a couple times in a very, very, very small amount of time, thousandths of a second. Which means that we can burn the fuel more efficiently in a much more precise time window of time frame. Which now all of a sudden that allows me to maximize my gas mileage on my vehicles. So this was found in vehicles that maybe got 15 to 17 miles per gallon at its best. This you can find in 30, 40 miles per gallon easily. Okay, you will not find a vehicle without this type of system. Okay, this presentation is really geared towards the modern day ignition system, mostly due to the fact that's what you are going to encounter. Okay, on most modern day vehicles. But again, I do want to let you know our shop cars, our shop vehicles are going to have a mix of distributor, distributorless, and direct systems. You should be able to look at where the spark plugs are at in the vehicle and be able to identify which one of those 3 systems that vehicle is using. Okay? Now, regardless of what system it is, distributor, distributorless, or direct, they all operate roughly around the same principles. Okay? And that principle is going to be divided up into 2 halves. We have our primary circuit, which is going to consist of our quote-unquote low voltage. So this primary circuit is battery voltage, 12.6 volts. Every vehicle has 12.6 volt system.
Mine's got 14.
Okay, we're trying to get up to a 48 volt system. That's going to take a little bit of ingenuity and pushing. But as of right now, we're at a 12.6 volt system. So any electrical system that's running off of battery voltage is considered part of the primary circuit. Okay? Unfortunately, 12.6 volts is not enough electromagnetic force to push electrons across the gap at the spark plug. 12.6 volts is not enough energy to be able to ignite our spark plugs, which means we can't ignite our air fuel mixture. So our ignition system needs to create a secondary circuit which then converts 12.6 volts into 30,000 volts. That higher voltage is on the secondary circuit. So we got a primary circuit, secondary circuit. The secondary circuit is only utilized in the ignition system. Okay, it's the only system in the entire car that utilizes that higher voltage. Even hybrids are going to have a low primary circuit and a secondary circuit.
Can you stop right in the end? We don't mind nobody. It's not even.
Kick him out. Kick him out.
Miguel, hi. No, we're not going to do that.
I have to cut that one out.
Thank you.
You're gonna have to edit the YouTube video now.
Primary circuit, secondary circuit. So the question I have for you then is, how do we convert 12 volt battery voltage? Whoops, excuse me. How do we convert 12 volt battery into 30,000 or more secondary
I'm gonna guess the ignition.
circuit volts?
I'm gonna say the ignition coil.
Probably the
Yes!
ignition coil.
Oh my goodness, you're correct. The ignition coil. The ignition coil is an ignition system. All it's going to do is transform.
Is that how it sounds?
Transformer.
Oh, I understand it now.
The switch in my brain got flipped.
Oh, there you go. See,
Light
that's
bulb.
how I know I'm on track. You guys understand what the noise I was trying to make. This transforms the boring 12.6 volts into something a little bit more exciting like 30,000 volts.
That's a lot of volts.
It is a lot of volts.
Maybe that's how
Okay.
it feels like.
Now the fun part about this is this ignition coil has no moving parts.
What?
Yeah, what's
Right?
on the inside of that?
That's a good question.
Nikolai Tesla.
So literally, it is like a little magical box. 12 volts go in, 30,000 volts come out.
Oh.
How does that do that? We're going to talk about it because
A lot of
listen.
A lot.
There's a very simple scientific principle that we utilize in order to transform 12.6 volts into 30,000 volts. Okay? So hopefully you were paying attention in middle school in science class because it's going to come back to in big effect here. Okay?
The wall and just starts. I don't know how the
No, that's not how that works.
They
So-
bounce and it multiplies.
Let's talk about how ignition system works momentarily, because this is a great example or a great picture of what this looks like. Okay?
Energy. The energy thing.
On the inside, if I were to cut this ignition coil in half, and you were to look on the inside, you're going to see, basically, we're going to have a metal rod. Okay? Probably not. Okay? That metal rod is going to basically have a electrical wire. This is, well, you know what? Maybe I don't use this as my theme picture.
Should I be drawn there?
Probably not a bad idea. But anyways, this is going to have an electrical wire wrapped around this metal rod. Now,
You pushed it down. Can't see.
in science class, maybe in elementary or middle school, maybe even high school, did you ever run an experiment where you took a nail and you wrapped a bunch of wire around it, and then you took those wires, you put it on a battery?
You stuck it
Yeah,
in all
blew
of
up.
it.
Okay. What happened to that nail? What did it turn into?
Red.
It
turned bright red.
What did it turn into?
I don't know.
Red.
Huh? Not a conductor, because metal is already a conductor.
Heat.
Not heat.
And more electricity.
A solid melted.
Spark?
No, it just turned red. And blew it.
If I were to go to the junkyard, right? If I go to the junkyard, you get this. How do they pick up all this metal and move it and then drop it?
Magnet.
Right? So
that thing's up.
listen.
Oh, it turns into
As an electrical current is flowing around that wire that's wrapped around that nail, what does that nail turn into? It's turned into an electromagnet, right? Because we generate a magnetic field. So as I pump 12.6 volts as current into this wire wrapped around a metal cylinder, we generate a magnetic field.
What? How did we get that in the
Okay? We create a magnet. As soon as I stop the current flowing through that electrical wiring, what's then going to happen is that magnetic field that was built up collapses.
I bet.
Okay? Like, quick. Okay? As soon as that magnetic field collapses in on itself, what's going to happen is it's literally going to force the electrons that are kind of chillaxing in this outer wire, right, to basically be shot out like a bullet from a cannon.
Whoa, how come we do it?
Okay? So then all of a sudden we get 30,000 volts.
Bro, what?
So
then all of a sudden we get 30,000.
The faster that collapses, the more powerful that magnetic field was, and the faster it collapses, the faster we literally force those electrons in the secondary circuit to move.
So,
That's how we can transform 12.6 volts into 30,000 volts. 30,000 volts is enough force
to murder.
to jump across the gap that's in the spark plug to create a little mini lightning bolt, and then that is used to ignite the air-fuel mixture. Think of it like this. If I'm Evel Knievel and I'm trying to jump across the Johnson Street Bridge when the Johnson Street Bridge isn't there, if I'm going 12 miles an hour, am I going to make it?
No.
Absolutely not. However, if I get put into a cannon and get shot out of that cannon at 30,000 miles an hour, am I going to be able to jump that bridge?
You're gonna jump more than the bridge.
I'm making my way probably to Rosendale.
You want to make it up.
Okay? Question.
So,
Okay.
Does it mean like if we generate more than 30,000 voltage, the explosion will be like stronger?
200 mil.
Power? Is that not?
All our main goal is to jump across that gap at the spark plug. Okay? So here's the fun part, right? This is only going to produce enough electricity to jump across that gap.
Just enough.
Just enough.
What does it do with the rest? It says not.
It just doesn't, it gets wasted. Okay?
Damn,
So
it said
the ignition coil is going to produce just enough to where we can do that. And again, the computer is monitoring this, especially in this particular situation. So it knows how much it needs to be able to get through that. Oh, I'm going to have a second one here in a second. Maybe not.
What?
Okay?
What?
Now, as these get older, and as spark plugs age, there's more resistance, which now means that over time, these are going to actually produce more voltage. We're not going to get into that technicalities here.
Yo.
But it's important that you understand that the ignition coil is the ignition system component.
Those drugs on the ground?
Let's
do.
Let's just hold that. Where?
Your notebook is not open.
All right, get your notebook, get the Players cards, please.
Get it now.
Your notebook
I don't
is
need
not
your
open.
assistance.
Sorry.
It's not me to follow it.
All right, so inside, listen, inside our ignition system, or excuse me, our ignition coil, inside the ignition coil, we're going to have primary windings that are going to be part of the primary circuit, and we're going to have secondary windings that are part of the secondary circuit. But these windings are only inside the ignition coil. You have to keep in mind that the primary circuit is beyond just the ignition coil. The secondary circuit is beyond just the ignition coil. Okay? And again, there's a soft iron core. So that's the makeup of our ignition coil. Primary windings, secondary windings, soft iron core. Okay? Now, here's an old school ignition coil, as you can see here in the upper left-hand corner.
Yeah.
Here's a modern direct injection ignition coil, much smaller. I shouldn't even have that on there. Okay, let me do this right there. We also have ignition coils in our coil pack distributorless system. Okay, so these things do not need to be huge or bulky. They can actually be pretty darn small.
That's not what she said.
That's inappropriate.
Whoa.
Help! All right, here's our first question for today. Ignition system wires operating at battery voltage are considered part of the... I'm not trying to trick you.
What?
Remember, there's always one right answer and three wrong answers.
said, was it, yeah, was it?
Ignition system wires are.
My great jet ski.
Ignition system wires operating at battery voltage, 12.6 volts, are considered part of the I get you. There we go. All right, we get everybody? I think so. Okay. Hey, you guys did better than first hour. First hour got 68%, you guys got 71%.
That's like one person.
That's always one person, right? Jesse, what'd you get?
Primary circuit.
Primary circuit. Now, keep in mind, let's see here. Are there primary windings inside of an ignition coil? Yes, but we're talking about the entire ignition system here. And every part of the ignition system that operates at battery voltage is part of the primary circuit. Okay? Important to know that. Every part of our ignition system that operates at 30,000 volts, that's part of our secondary circuit. Primary windings are inside of our ignition coil that does run off a battery voltage, but because it's the windings, it's inside the ignition coil. An ignition coil is not the only part that has these parts of the circuit. Okay. Oh, we're doing pretty good. All right. Again, emphasization on how this works. The primary circuit's magnetic field builds up when the primary circuit is closed, meaning that it's turned on. Okay. So for instance, right now in this classroom, all the lights are off because the electrical circuit is open. There's a break in the electrical wiring right now, which does not allow the electrons to flow in the wires. So it's open.
Yeah.
As soon as I close that circuit, it allows the electrons to start flowing, which then allows the lights to be energized.
That makes sense.
Okay?
That's crazy.
Let me do this because otherwise it's going to take too long. Oh, it's way brighter than normal. Now, as the primary circuit is switching between being opened and closed, right? As soon as I close the circuits in my ignition system, electrons are flowing through that wire, that magnetic field is building up. As soon as I open that circuit, basically flip the switch off, the electrons stop flowing, which means my electromagnet and the magnetic field collapses.
Oh, baby.
That magnetic field, as it is collapsing through the secondary windings, is what energizes and forces the electrons to flow out of the ignition coil at a much higher pressure, much higher voltage than what was used to go in. That's how that works.
I understand.
Okay, it is a fundamental idea about how the ignition system is able to spark the spark plugs. If we couldn't do this, vehicles don't spark, we don't run. Okay?
R.I.P.
Now, when the circuit is turned on or off, that is completely controlled by our ignition control module, a computer. Okay? The computer is literally standing by the light switch and going, okay, magnetic field is building up. I want to fire the spark plug. Boom, fired the spark plug. Okay, turn it back on and start building that magnetic field up. Oh, I need to spark the spark plug. Boom, I fired the spark plug. Okay? Like literally, that's the computer's job. Turning that switch on and off. That's all it's doing.
I want to be that computer.
Again, when the primary circuit is opened, the primary magnetic fields collapse through the secondary coil winding, which induces a higher voltage surge for electrons to jump the gap in the spark plug. Okay, here's a very important vocabulary word. Primary circuit close time is known as dwell time. Okay? So again, lights are on. I'm dwelling. The magnetic field is building up. Okay? Think of it like a cannon. You put air. You ever use like a potato gun?
No.
You put the potato in a PVC pipe, and all of a sudden you add like pressurized air. You keep adding pressure, keep adding pressure. Eventually, that pressure becomes so great, the potato shoots out. Same kind of concept here. Okay? I've got an electron in my ignition coil. And what I'm doing is I'm building up that magnetic field. Building it up, building it up, building it up, and all of a sudden, fire my laser! Boom! That sends that voltage, shoots those electrons out. Right? Boom! Dwell time. Dwell time, dwell time, dwell time. It's on, it's on, it's on, off. Dwell time. This is when dwell time is, when it's on. All of a sudden, this is when the magnetic field's charging up. I'm about to fire my laser. Boom! Oh, charging it up. Boom! Okay? That's the idea behind this concept.
What is it shooting out?
Electrons. Electrons. All right, this is going to be our last slide. Actually, you know what? We're going to save this for tomorrow.
Thanks, baby.
Save this for- All right.
There you go, baby.
I'm ready to eat some lunch.